And so we're going to start chapter 11, infinite sequences and series. And there are some tools that you need for chapter 11 that you might have seen before, but you might not have seen these tools before. So I want to go over this with you. And I will call this 2 tools for chapter 11. 2 tools for chapter 11. One of the tools is factorial. And the second one, a little bit of logic. Just a couple of basic examples of each one of these. Raise your hand if you've heard of factorial before. Okay, raise your hand if you've never heard of it. And maybe you've heard of it, but you didn't remember the name of it. So here's the definition of factorial. Factorial is this. It's a multiplication, and it's multiplication where you start with a positive integer and you multiply from that integer all the way down to the integers stopping with 1. So multiplication where you start with a positive integer and you multiply together all the integers from that positive integer down to 1. So maybe I could say it, you multiply the integers that are between 1 and the number you're doing the factorial of, inclusive. You can include 1 and include the number you're doing the factorial of. So here's some examples. Oh, and how do we write factorial? Exclamation mark. We write this with an exclamation mark. So here's an example. If I want to do 5 factorial, I would read it as 5 factorial. Then that's 5 times 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1. And if you get your calculator out, you can multiply it. And actually your calculator probably has a factorial key, but that's going to be 120. What about 2 factorial? 2 times 1 is 2. How about 1 factorial is 1. 0 factorial, that's 1. I did say start with a positive number, but you know what? We could do 0 factorial, and that equals 1. Now this 0 factorial, this is by definition. And when mathematicians say something is by definition, that is, they're saying because we said so. You know, like your mama telling you, because I said so. 0 factorial is 1 by definition. So here's another problem that I might want to do. How about 29 factorial divided by 25 factorial? this one, I'm going to write out this a little bit. And this would be 29 times 28 times 27 times 26 times 25 times 24 times 23. I'll put the 3 dots. 3, 2, 1. And then I'll divide that by 25 times 24 times 23 times, I'll put my 3 dots, all the integers in between, 3, 2, 1. And for this one, since it's written in this fraction form, I can reduce the 25, 24s, 23s, everything down to 3, 2, 1, and I am left with 29 times 28 times 27 times 26, and I'm gonna use this calculator I borrowed. 29 times 28 times 27 times 26, and I have this equals 570,024. Now, if you look carefully at your calculators, you probably have a factorial key somewhere on there. I don't see it on this one, but look at your calculators and find out where your factorial key is. Okay, top right. Oh, right there, factorial key. So if I wanted to do 29, I could do shift factorial divided by 25, shift select factorial equals, and there's my answer as well. Thank you.